Hello rocket enthusiasts, welcome to the VGEC Rocketry team. In this video we are going to design a flight computer for our rocket Venessa. Let us name our flight computer as Rocket Now. So let us design our rocket now first. Now for designing I am going to use KiCad, that is an open source software suite for designing PCBs. Now Venessa is a two-stage rocket. So when designing its flight computer, it's essential to understand the key objectives of the flight. The flight computer must accurately record the apogee, precisely time the ignition of the second stage motor, and deploy the parachute at the correct moment to ensure a safe landing. To achieve these objectives, we'll need the following components for our flight computer. ESP8266 as the microcontroller to handle all the data processing and decision making. BMP280 to accurately measure height and track the apogee. MPU6050 to monitor acceleration, helping us with precise timing for the second stage ignition. 3 screw terminals for secure electrical connections. 2 pair of transistors to control the ignition of the second stage motor and the deployment of the parachute. A LiPo battery to power the entire system. And finally an LED for status indication and debugging. So let's start our first task, that is to design our PCB. So let us make a new project in KiCad. Now to make the schematic, we will use schematic editor. Now in schematic editor, we have to add all the components that we are going to use to make our rocket now. So using this icon, we can add the symbols of all the components. Let's add node MCU, which is also known as ESP8266. As you can see, we have got a node MCU symbol. Similarly, we will add all the other components. So as you can see, we have got the symbol of all the components that we are going to use. Now we have to make the connections. So the labeling is more efficient way to make the connections. We will use the labeling method. So let us make all the connections. So here we have made all the connections. So let's add footprint to each and every symbol. So we have added all the footprints to the symbols. Now let's switch to the PCB editor. Now we have got a space of 77 by 39 mm to make our FC fit into the rocket body. So let us make a rough rectangle of the given dimensions. Now we have to fit all the components in this box. Now as we are going to use box strips to mount the node MCU, we will get some space to fit the transistors below it. So we'll place the transistors here. Now we have fitted all the components in the given box. Now let's make the tracks. So to make the tracks, we will use this icon. We can make the tracks as simple as that. Similarly, let us complete the whole PCB by joining all these blue lines. Now to connect these blue wires, we cannot jump over these tracks as we are making a single layer PCB. So we will use the vias to connect these terminals. For that, we'll make a track and add vias to the tracks. We'll increase the diameter of the vias. So now our PCB is completed. We'll get a printout of this and we will see manufacturing in the next video.